Hello everyone, hello and welcome. This is Aurora with the Central Coast Astronomical Society, and I am so excited you're going to be joining us tonight. Hello. What do you guys think? You guys ready? Kent, you ready? Everybody ready?
I'm ready.
All right, go ahead and buckle up because here we go. All right, so let me introduce you to our astronomers tonight. So first, Brian, why don't we introduce everyone to you? You ready to say hi?
Hi everyone, I'm Brian, and also with Central Coast Astronomical. Excited to join you tonight, and we're looking forward to an awesome show.
Awesome, thank you. And Kent, Kent is not going to be by visual tonight. Kent is only by audio for a couple of reasons. The reason number one is that while he's talking, I'm going to be sharing my screen of the night sky with you. The second reason is because once upon a time, Kent actually would just sit and talk to us because he had a rotary phone. So Kent is an incredible astronomer, knows a lot of detail. He actually has been helping me correct some of the information I've received just on regular research through books and through the internet. So he's an incredible resource. And if you haven't had the pleasure of learning from him, this is going to be your night tonight. So, all right, everybody got their spaceship? You battened down the hatches and got your big old harness on, ready to go? All right, hit the throttle because here we go. Kent, are you ready? So I'm going to be sharing my screen with you. Kent, what is the first object we are going to be going to tonight?
Okay, we're going after Gemini, which is part of the Great Hexagon. And I don't know if you remember last month we hit two of the constellations of the six in the Great Hexagon. We hit Taurus, the bull, which has Aldebaran. I don't know if you can point that out. There's Aldebaran in the bull. And then the other constellation we hit last month was Auriga, which looks like kind of like a pentagram. And the bright star in Auriga is called Capella. And actually the Great Hexagon is composed of 6 constellations and actually 7 bright stars. And so you've got Aldebaran, you've got Capella, down below you've got Castor and Pollux and Gemini, the twins. You go down a bit further and you've got Procyon, which is just at the edge. There it is. Procyon and the little dog, Canis Minor. And then you zip over to, actually you zip the wrong way, zip down towards the bottom is Canis Major, the big dog. That's Sirius, the brightest star in the sky. And then you zip over to the foot of Orion, and that's Rigel. And those 7 stars make up the Great Hexagon. You've got Betelgeuse right in the center. So tonight we'll be hitting Gemini, Canis Minor, Canis Major, and Orion.
Awesome. Okay, great. So you want to start with Gemini?
Yeah, let's start with Gemini.
Okay. So how do we find, I'm sorry, let's see, let's back up just for a quick second. Where is Gemini?
Sure.
If we want to find it tonight, it's nice that I can connect the dots and put names and labels on things, but normally it looks like this. So,
and to tell you the truth, this is a good time of the year for the Great Hexagon. Even Sirius, which is the lowest bright star, is still good, up in the sky pretty decently.
Yeah.
So this is really well placed in the sky for quite a few hours tonight.
Nice. And so where in the sky should we be looking?
For
the Great
Gemini, you look for the pair of stars, the twins, Castor and Pollux. In fact, you've got it right there. In fact, if you blow that up, you can see it's 2 stick figures of the twins there. You've got kind of like the body going down with feet going out. There, you've got the lines in there. That's the H.A. Ray lines. Those look really good. And there's some mythology between Castor and Pollux. It turns out that Castor was mortal and Pollux was immortal. And they went on the voyage with Jason and the Argonauts to get the Golden Fleece. And so they're tied in with sailors. Actually, they're like a lucky charm for sailors. They use the term by Gemini that kind of evolved into by Gemini. And so that goes back. Also, when Castor died, Pollux asked his father Zeus to be, reunited with his brother, and Zeus put them both into the sky. So that's one of the myths about Castor and Pollux.
Got it.
And I guess we'll start with the northern twin, which is Castor. The bright star in the head there, or shown as a head, is actually a nice double. They call it Alpha Geminorum. To the naked eye, it looks like a white star in the head of the northern twin, and it's the 23rd brightest star in the sky with a magnitude of 1.58. Castor by itself appears about 49 times brighter than our sun, about 51 light years away. In a small telescope, it'll split into a nice pair of white stars, currently about 5.4 arc seconds apart.
Mm-hmm.
And that was really a good diagram you had there.
Yep.
Because you see the A and B are the two brightest, or the two nearby components of Castor. And the brighter of the pair is 1.94 for magnitude, where the other one is 2.92. You can see it's a bit dimmer, but it shows up nicely in a small telescope. The third star, the C star out there, is a bit tougher to see. It's about, let's see, I was trying to remember, it's like 72 arc seconds distant, so it's out there a ways. And it's actually a pair of red dwarf stars, so it's, a faint one.
Mm-hmm.
I think I'm trying to remember the magnitude. I think it's magnitude 9 something for 9.3 for the pair, and yet it's bound to the system. It must have a period something over 10,000 years for it to orbit. In 1803, William Herschel announced that the A-B pair, which by the way was discovered as a double by Cassini in 1678. So it took a few years before they saw the motion of one star around the other star. And William Herschel announced that they're a gravitationally bound pair. And that was the first true binary that was gravitationally bound by Newton's laws that they came across. And it takes about 460 years for the A and B components to go around each other. They'll have a maximum separation of 7.2 arc seconds in 2080. So it'll be a long wait for them to get the maximum.
Yeah, definitely.
And in addition, each of these stars, the bright white ones there, are very close spectroscopic binaries. The brighter component has a period of about 9 days. You can't see these in a telescope, but there's actually extra pair of stars there. The fainter star has a period under 3 days. So, the way they tell is they get the spectra of it, and the lines shift back and forth due to one component going around the other. So visually you can't separate them, but a spectroscope you can see the lines dance back and forth. And then the C one, it's only 19.5 hours for the two red dwarfs to go around each other. So we're seeing 3 stars, but really there's 6 stars there.
Wow, that's amazing. So what else do you want to share about Gemini?
We've got the other twin, which is Pollux. And the interesting thing about that, you can show that as it's the southern twin. You've got the northern twin and the southern twin. The interesting thing is Pollux is actually brighter than Castor. Yet Castor's given the Alpha Geminorum, and Pollux is Beta Geminorum, which kind of goes against the alpha, beta, gamma numbering, system. And was, yeah, Alpha. I think it was Bayer that did it in 1603. And yeah, you have Alpha as your brighter, then your next brightest would be Beta, and next brightest would be Alpha, Beta, Gamma. There it is, Gamma, Delta, and it just goes on down. And that's pretty much the rule he followed. And so there were some questions. Did Castor get a little bit fainter over time, or, you know, it all depends. Maybe the guy's eyesight wasn't that good. You just never know. There's weird things like that. And Pollux, to the naked eye, is actually kind of orangish colored, or an orange tint. It's the 17th brightest star in the sky at magnitude 1.16. So definitely brighter than Castor. 35 times brighter than our sun. It's also about 35 light years away and about 11 times the diameter of our sun. So that's the neat thing about Castor and Pollux. And the other day I was going out to my car at night, and I just looked up, and you could see them. They're kind of a neck breaker, but they're
they're straight overhead, right?
Way up there right now.
Way
yeah,
up there.
Way up there. Kind of hurts as you get older, your neck bothers you.
It does. It does. Oh, you know what?
So,
let me show people where it is. So how do you find Gemini? If you've never seen Gemini before, most people can find Orion. That's a pretty easy one to see. So here, let me show you. So you go outside, you look up, and it looks like this. Oh, I've got my planets labeled. Let me take
there's
that off.
actually a real easy way I can see from the chart there.
Can you?
You see
Here.
Rigel in the foot of Orion.
Uh-huh.
And then you've got the belt. Well, draw a straight line from Rigel to Betelgeuse, which is the orange one. Keep on going. And that straight line
Gemini.
runs you right into, Castor and Pollux there.
Nice.
So that's one way to point. But, yeah, they're up pretty high.
Yes.
And so, if you're starting from the horizon, you can always start with, like, Sirius and work your way up, which is Canis Major. Mm-hmm. And then Orion's hard to miss. I'll see Sirius first. Then I'll look up and I'll see Rigel. Then I'll see the three in the belt. The thing about Orion is those three in the belt just really stick out because they're about the same brightness, they're about the same separation, and they're in a line.
Yeah.
And so that's, when I started learning the constellations, that was one of the first ones outside the Big Dipper that I went for with my binoculars and the HA Ray book, because it's such an easy thing to start with. It hangs out in the south there. And you're kind of like going, what is that?
Yeah, so again, just find Orion, find his really bright foot star, connect it to up here near the shoulder, and then draw a line, and you're going to see Castor and Pollux there. Okay, great. Did you want to talk about the shoe? The shoe of Gemini?
Yeah, let's talk about the shoe buckle.
Okay, great.
It's a Messier object, M35.
Okay.
It's an open cluster just above the foot of Castor there. In fact, you can see it there. They got a fuzzy blob. As you're enlarging it, you can see it's right above the foot there. They call it the shoe buckle nebula. And
it does not look like a shoe buckle.
I read somewhere is because it glitters on his northern shoe, so it's called the shoe buckle nebula. And M35 is about 2,700 light years away, so it's out there a ways. It's magnitude 5.1, so if you're in a dark area and you have a good night, you've got decent eyesight, you'll probably be able to pull it in as a fuzzy patch. It shows up real nice in binoculars. If you got like 750s or 1050s, M35 shows up really nice. The age of the cluster is about 125 million years, so it's not really young, but it's not really old either. It was discovered by a Swiss observer, Philippe de, and I'm going to butcher this, Canis or something like that, in 1746. It's really a nice cluster. And the cool thing about it is it's a twofer. If you look at M35 in a telescope, you'll find there's another little cluster about 30 arc seconds arc minutes to the southwest of M35 is a little open cluster called 2158. And the cool thing about 2158 is it's 12,000 light years away, yet it looks relatively bright in comparison. It's 8.6 magnitude and has a diameter about 5 arc minutes, but it's over 4 times the distance of M35, and yet it shows up fairly well. It's fairly a dense cluster. It contains about 1,000 stars, and the interesting thing is it's 2 billion years old, according to one of the references I have. That's really, really old for an open cluster. Open clusters are usually in the disk of the galaxy, and just the movement through the galaxy tends to strip away stars. So unlike globulars, open clusters get kind of destroyed over time. So this guy must be far enough above or below the disk to stay intact for that long. So that's kind of a cool thing. There's like an arc, yeah, there's like a curve of stars. Your binoculars would be really good to use. In fact, you notice how you've got Castor and Pollux. If you take like a right angle going towards Orion out of Castor, you go right down the body and you get into those 2 bright stars in the foot, continue for the third, and boom, you hit that M35 right there. And that shows up pretty well. Yeah, it's a two for one view and 2 objects. In my C8, I could see both of them. In my old eyepiece, I think my old eyepiece, I had like a 32 millimeter Erfel, and I could get about a 45 arc minute field. So yeah, I'd get both of them in M35.
Yes.
Have to move M35 to one side and have 2158 on the other side.
Perfect. And I know my microphone has been going in and out. I just fixed it again, so I'm so sorry. So just to reiterate my comment there, Kent, let me interrupt you for a second. Brian, how am I sounding now? Good?
Well, I hear you from Zoom, so I can't tell.
Okay, it looks like the levels are up again. So again, here,
Okay.
here's
Thank
my
you,
face.
everyone.
Thank you. So I fixed the microphone problem. So my apologies. What I was just saying is, if you can't find it, sometimes I'll interrupt Kent and say, wait, how do we find this again? So here's what we would do. Do you see how we've got Orion here? And we've got the belt stars, and then we've got the foot, and we're going to use Kent's, we're going to connect the foot with Betelgeuse, and then we're going to come over here to find Castor and Pollux, and then there's a curve right here, and it's right here at this curve that you're going to get that 2 for 1. So using binoculars, you'll be able to see the shoe buckle cluster as well as the NGC, the other one he was just talking about, NGC 2158.
2158.
Yes.
I think you may need a telescope to
see
pull in 2058 since it's an 8.6, although your big binoculars should do it.
Okay, perfect.
But if you had 10 by 50s, maybe, if you had good night and good eyes, you might be able to pull that guy in.
Okay, great. Perfect. Now, I didn't know about the jellyfish cluster, but probably a lot of you did. So, Kent, why don't we go there? Jellyfish.
Yeah, it's actually index catalog number 443, the Jellyfish Nebula.
Mm-hmm.
And if you actually look at an image of it, it does kind of look like a jellyfish. In truth, it's really near Eta Geminorum, which is also in the northern foot of Castor. It's about 45 arc minutes east-northeast of it. But if you look at it, it's got like, how jellyfish has the dome. You can kind of see the dome there. Then you got the hangy downs, which are the tentacles. And so that's how they came up with the jellyfish cluster. It's also about 2.5 degrees southeast of M35, so it's not horribly far away. The actual size of the jellyfish cluster is about 30 arc minutes by 15 arc minutes. So that's good size.
It's a big size.
It's about 5,000 light years distance. It was discovered somewhere between 1888 and 1894 by means of photography by E. Barnard and Max Wolf. I had to go the original source to dig that out. What they call the NGC/IC catalog, and I could not find an exact date for the discovery of this guy. The IC443 is really faint. It probably requires a 12-inch or greater scope with the use of an O3 filter.
Okay.
I know I've seen the head of the jellyfish in my 20-inch using my 2-inch O3 filter. I was able to pull in that brighter part, the head of the jellyfish there. But it's not an easy object. It's just kind of cool.
So that's our challenge for those of you seasoned astronomers who want to try to find that. Okay.
Yeah, or take a photo of it. You can get away with a lot on photography.
That's true. That's true. You can.
Also, let's see. You want to go to the next one?
Yes, yes. This is one of the first ones I've
cool.
seen. Yeah, the next one is really cool. Let me
It's
know
a planetary nebula.
It is. This is Kent's bread and butter right here. He loves planetary nebula. You ready, Kent?
Oh yeah, yeah.
Okay, go for it.
I'm like a big tourist when it comes to planetary nebula.
All right. So NGC. What's the number again?
Okay, it's NGC 2392.
Okay.
And it's called the Eskimo Nebula. So we got to shift over to the hip of Pollux.
Yeah, there we go.
We've been looking at everything in Castor. Now Pollux gets to shine.
Okay, so it's right here.
It's a bright, small planetary. It has a magnitude of 9.2, a size of 47 arc seconds by 43 arc seconds. There's a central star that's magnitude 10.5, and it's about 3,800 light years away. It was discovered by William Herschel on January 17th, 1787. And it's called the Eskimo Nebula because on some of the old black and white photos of it, it looked like it was, someone wearing a parka with a face inside. And what we're seeing here is a Hubble shot. It looks more like an angry Vorlon out of Babylon 5. But it is a wonderful planetary nebula, and let me tell you that Hubble shot blew everyone away.
Yeah.
That the detail that it showed.
Yeah.
But it's a really nice planetary nebula.
Exactly. So just to recap before we move on to the next constellation, we are going to mess up the sky a little bit. You walk outside, and you pretty much look straight overhead. And then you're going to find Orion. You're going to find the belts stars. You're going to find the foot. You're going to connect it with his shoulder. And then you're going to find Castor and Pollux here. And so you'll notice there's a curve in the top one. And then this one comes over here. So around the curve in the foot area, you're going to see two objects. And we got the shoe buckle cluster and one you'll need a telescope for. But then if you kind of come back along that curve, you're going to see the jellyfish cluster. And then if you zoom back over the hip area, this is one I have to highlight because I don't remember exactly where it is. By the way, Kent is not reading any star charts. He does most of this stuff from memory, just so you know. So Kent, Eskimo Nebula is NGC
2392.
92. Okay, great.
It's kind of off the hip of
right here.
Of Pollux. The star that kind of makes up the hip is actually called Wasset. Watset.
It is.
I thought a funny name. It's Delta Gemnorum, but for some reason it's called Wasset or Wasat. W-A-S-A-T.
Yes.
Which is kind of a funny. At least it's short and pronounceable somewhat. So.
It is. Nice. Okay, great. Before we go on, Kent, we've had a couple of people ask, where is that hexagon again? So let me just highlight that real quick.
Okay, yeah, because it's real prominent now, kind of over in the southeast. And it has all those bright stars in it.
Yes.
Sirius is the brightest star in the sky. Pollux is a bright star. Castor and Gemini are okay. Capella's a bright star. Aldebaran's a bright star, and Rigel's a really bright star. And then right kind of in the center, almost the center, is Betelgeuse, which is a bright kind of slightly reddish or orangish, I guess really more orangish than anything star.
Yeah.
So.
And this one is huge. It's a huge hexagon. Look, Orion is only part of it. So when you look up, look bigger than you think you need to, and you'll be able to see it.
Oh, yeah. And, it's a lot of bright stars it's still a good size area, but, it's something where you find something you can recognize. And the belt of Orion for me was where I started. Those 3 stars in the belt are hard to miss.
Yeah, they are.
They're the same separation, about the same brightness, and all lined up. So that was a good starting point to learn the constellation of Orion.
Perfect. Okay, great. Let's go ahead and move over to the small dog. Are you ready for him?
Okay, we'll go for the little dog.
The little dog. Where
Which
is
there's
he?
not much to the little
There's
dog.
only 2 stars.
It's really a sad constellation.
This is it.
It's kind of like the little dog really doesn't get much to eat. And, it's a pitiful, little constellation. Doesn't have any nice open clusters or planetary nebulas or anything cool like that. But Castor itself is an interesting star. So let's.
Castor or Procyon?
I'm sorry. Yeah, I should have said Procyon. Yeah,
we can go back to Gemini if you want.
Gemini. Yeah, I'm still with Gemini.
No problem.
Yeah, we
no
gotta
problem.
Go for Procyon, which is Alpha Canis Minor, or Minoris. It actually means before the dog. And there's a legend tied in with it and with Canis Major, the big dog. They're hunting dogs of Orion, who's the hunter. And so those 3 tie together. And so that's a little bit of mythology tied in with these guys. But Procyon means before the dog because it would rise before Sirius came up. It's the 8th brightest star in the sky with a magnitude of 0.35. So it's pretty bright. It's a white main sequence star, which means it's still burning hydrogen in the core. It's fairly near. It's 11.3 light years away, so that's pretty near. It's got about 1.7 times the mass of our sun, and it's about 2.3 times the diameter, about 6 times brighter. So it's kind of a neat star. The cool thing is what you can't see. And Procyon had a wiggle in its movement across the sky, and they theorized that there was another star you couldn't see that was causing the wobble in Procyon's movement across the heavens. And they did some calculations and worked out whatever this dark body is, it has a period of about 40 years, and they calculated that out in 1861.
Wow.
And it took until 1896, so we're looking at, 37 years? A gentleman by the name of J.M. Shuberly, I had to write that down, and I probably just butchered his name. My apologies to him. But he was using a 36-inch refractor at Lick Observatory, and, it was the largest telescope in the world there for a while. And he was able to see the companion. It's called Procyon B, where the brighter component's Procyon A. It's a white dwarf with a magnitude of about magnitude 11. It's got about 65% the mass of the sun and a diameter twice that of Earth. It's got a period of 40.7 years, so they were pretty good with their calculation.
Wow.
The separation of these two stars varies between 2.2 arc seconds and 5 arc seconds. It's currently about 4.6, but it's not a target for amateur scopes because Procyon is so bright, you just can't pull it in unless you have something like a 36-inch lick sitting around and you hit it at the right time.
You know, mine are just too small.
Yeah, I mean, maybe if you had, a big scope and really good scene, and it was overhead, and, you just had a miracle thing, you might be able to pull it in. But, it's one of those, it's a really, really tough object. It's just cool to think about, there's this dead core of a star that's going around Procyon and actually causing Procyon to wiggle in its motion through the sky.
Wow.
So that's the cool thing about
that
it.
That does sound really cool. So do you want to move on to the dog, the bigger dog, Canis Major?
Yeah, let's go to Canis Major, the large dog.
All right, let's go find him.
It's a hard to miss constellation with
it's the brightest star in the sky.
The brightest star in the sky right there.
Okay, so here, where are we? So we're looking south. We're going outside, and we're looking south, and then we see the brightest star in the sky.
Yeah, I mean, when I drive to Vaughn's, even though there's all these lights in the parking lot, I can look up and see Sirius.
So if you still can't find it and you're not sure, like, is that one brighter? This is one you can see in New York City. Not during the daytime, but during the nighttime. Also look for Orion's belt. It'll point right to Sirius.
Yeah, I mean, it's really a neat star.
Yeah.
It's also called the dog star. And it's the brightest star in the sky excepting our sun. Some smart guys will say, well, the sun's brighter.
Like, well, we're not talking about that. I hate it when people do that. Like, you know what I'm talking about.
I think it's like minus 26 or something like that.
I think you're right.
Our sun's magnitude.
Sure.
Yeah, this one's it's a minus 1.46. That's, really good.
So when you say minus, now you're saying -2 is greater than -1 for magnitude.
Right. The numbers, instead of getting, they're actually getting smaller, but people just look at the size of the figure.
Right.
People don't like negative numbers.
Oh, that's okay.
But you get it when you're in algebra and that sort of thing.
Well, here's a practical application. So there's the dog starts. How big is Sirius? I know we were trying to figure this out.
Okay, it's about, the dog star itself is about 1.8 times the diameter of our sun. It's about 2.35 times the mass. And distance-wise, it's only 8.6 light years. So it's the nearest naked eye star, with the exception of Alpha Centauri, the Alpha Centauri system, but you have to be in like the southern hemisphere to see that.
Right.
But that's why Sirius is so bright, is because it's relatively near. There's also a white dwarf companion, and I did some research on Wikipedia and looked around and Googling stuff, and I was wrong about the diameter, or I had old information. Sirius has a white dwarf, and you can see that on the slide there. And there's that one little faint star to the lower left. That's the white dwarf, and it again was it was making Sirius move back and forth as it's moving through the sky. It has a period of 50 years was calculated in 1851, and the actual white dwarf was visually observed on January 31st, 1862. So it took a little while for it to be observed, and the famous American telescope maker Alvin G. Clark was at the time testing the largest refractor in the world. And at that time, it was 18.5 inches. And, he actually made the lenses that went into that refractor. and it was at the Dearborn Observatory.
Wow.
And he just happened to look at Sirius. You know, he knew about this object, and sure enough, he pulled it in. Guys have been trying to pull it in for like over a decade.
Wow.
And he managed to pull it in. And the interesting thing is, it's one of the heaviest white dwarf companions. It's the figure I saw was it's 1.02 solar masses. And the weird thing about white dwarfs is the more massive they get, the smaller the diameter. The diameter is slightly under the size of the Earth, where my older information said it was like twice the size of the Earth.
Oh, yes, that's right. We were talking about this. So, you know, we're not 100% sure, but this is the best information we can get you right now. And in fact, a lot of the... Yeah, go ahead.
You know, and you know, I get the feeling they don't want to talk about it too much because there's another factor that ties in, and that's how old the white dwarf is. As they cool down, the diameter can change a bit. And so that can make an effect also.
Yeah.
And so, you know, all depends on the age. They're really, really hot when they're first born, but then, you know, they still stay fairly hot, you know, for extremely long times. I remember reading something about how they can still be hot. In fact, they said the first white dwarfs born in the universe haven't cooled down yet. They're
Wow.
still hot. That's about 13.8. Actually, you know, they took a while to get a white dwarf born, but let's give them a billion years. So like 12 billion years, and the thing's still hot. And so I thought that was kind of an interesting thing.
Yeah, totally. So the Sirius B also has a nickname, right?
Yeah, they call it the pup, you know, or Sirius B, and it does have a period of 50 years, so those guys got it right. It's got a magnitude of 8.7. The interesting thing is I've seen it once.
When?
In my 20-inch.
You have?
And I was out at Navajo Flats, and I was actually we were talking about a technique on Amastro, which is an e-group of amateur astronomers from all over the world. And I went out there, and one of the guys suggested that if you get it while it's still, you know, somewhat light out, still dusk, that may inhibit the light coming from Sirius and make the pup show up better.
And it worked?
And so I was sitting out there. Yeah, it did. You know, I was
Wow.
sitting out there with my 20-inch, and the really important thing is you have to have good seeing. And I could see all 6 stars in the trapezium in the center of the Orion Nebula.
Wow.
Where normally you see 4 stars. I could see all 6, so I had really good seeing. And I kept drifting back and forth between Sirius and that. And as it got darker, I know some of the background stars were coming in. And then, boom, there was the pup, really, really close to Saturn. And I made a drawing of it because I wanted to make sure that I really saw it. So when I got back home, I pulled out a chart that showed which side of Saturn, or not Saturn, Sirius it's going to be on. And sure enough, and the other cool thing, it was between the diffraction spikes.
Oh, let me show that again.
You know,
yeah.
You know, that one picture, you can see the diffraction spikes on there. That's caused by some supporting mechanism for a mirror or something like that in the scope. But you can see if that little star there, the pup, was on a diffraction spike, he'd be out of luck.
Yeah.
And mine happened to be up a bit further to the upper left when I saw it there.
Nice.
But that was the first time in my life I'd ever pulled in the pup.
Oh, wow.
And as it got darker, the pup got harder and harder to see. And so the dusk effect was working for me. And when it got fully dark, it was really, really difficult. I don't know if the scene went worse or it was the effect of it getting dark, but
that's awesome.
That technique worked.
Yeah, it does. Now, the next one you're going to share, I like because you can see it in binoculars really easy.
Oh, yeah, M41.
Yeah. Do you want to go there?
M41 is really nice. It's a nice open cluster. Has a magnitude of 4.5, so if you got good eyes, or dark sky, you should be able to actually see it as a fuzzy patch. You kind of just drop straight down from Cirrus, and boom, it's really easy to find in binoculars. It's one of the ones that was discovered by Holdernia in 1654. Last month we talked about all those 3 open clusters in Riga. I think M37, M36,
Yes.
and M38.
That's right.
Those were also discovered by Holdernia from Sicily, and in 1654. But his paper got lost until like 85 or something like that. So they didn't know he'd actually found about 10 deep sky objects, or was the first person to actually know them in a list.
Wow.
M41 is a nice open cluster. It's 2,260 light years distant. It has an age of about 190 million years.
Whoa.
And, it's just a nice, it's about 4 degrees south of Cirrus. So it's really an easy, one to find.
It is easy. So here, let me reiterate for people. So here we are. Let's turn off this and this. We're going outside. We just had dinner. It's sunset. We're going south. And we're looking up, and hey, we're pretty good at finding Orion. The belt stars point straight to the brightest star in the night sky. Boom, there it is. And here's his head. Here's his little feet. And if you drop straight
kind of like the
down,
hindquarters for the dog there, that triangle.
That little triangle.
At the bottom. And then you got that little foot out in front there. And there's actually a little curve of stars going off Cirrus, almost makes like a doggy head there to the
is this what you mean?
Left and up.
The left and up. Oh, this here?
Yeah, that's kind of like the doggy head that ties into Cirrus.
Here, let's see what it looks like with the lines on.
At least that's kind of like what I see.
Yeah.
Yeah. So Cirrus is actually is pretty easy to pull in. The stars are bright, and in the HA ray book with the pair of binoculars, you got it made.
Yeah.
Yeah, it really brings it in.
Perfect. Yeah. Now this next one, I laughed so hard when Kent told me about this one. I actually have never heard of this
next one is NGC 2359. They call it Thor's helmet.
Let me show the picture from the European.
It really does look
it
like
does
Thor's
look like
helmet.
a helmet. This is from the European Space Agency. Let me show you the picture first. What do you guys think? Does that look like a helmet? Tell me in the chat box. What do you think? Does that look like, would you name that Thor's helmet? What do you think?
You can see the dome of the helmet there, and then you see the wings on either side. So it's kind of like Thor in the comic books. It's kind of like the helmet Thor would wear in the comic books. So
yes. All right, so let's...
Someone called it Thor's helmet. And what it is, it's actually a rare object. It's a Wolf-Rayet Nebula plus star. And you can see that one bright star in the helmet. That's the Wolf-Rayet star. It's a rare object. I don't know if we've even discussed the Wolf-Rayet Nebula.
No, I don't think we have.
It's magnitude 9.0, so that's not bad. It has a size of about 13 arc minutes by 11 arc minutes, and was discovered by William Herschel on January 31st, 1785. The Wolf-Rayet stars at magnitude 11.5, and it produces a fierce stellar wind. It kind of snow plows all the gas and dust into a bubble in front of it. And it can be seen in an 8-inch scope with an 0.03 filter. Really helps make it stand out. It's located in the northeast corner of Canis Major. So you can see how you got that front foot and you got Cirrus. If you extend the line, about, what would you say, twice the distance out, and go up a little bit,
it's right there.
You're in the general area, and then you start looking for something nebulous, and if you have an 0.3 filter, then you pop it in, and it should show you the helmet.
Perfect. Awesome. Okay, great. And then there's the open cluster we were going to cover. There's
actually a real cool open cluster called the Tau Canis Major cluster, or NGC 2362. This is down in the hindquarters of Canis Major. And when you're, you see how there's one bright star?
Yes.
And then there's all these other little stars clustered around it. Visually, it is a cool object, whether you're using a 20-inch scope or an 8-inch scope, it really stands out. It's got a magnitude of 3.8, so that's fairly bright. A diameter of only 7 arc minutes. It's about 5,100 light years away and an age of only about 5 million years. So it's a fairly new cluster. It was discovered by William Herschel on March 6, 1785, and it's located about 2.7 degrees east-northeast of Delta Canis Major. But yeah, the photograph doesn't do it justice. When you see it visually, you see this really bright star, and then there's all these little stars clustered around it.
That is so cool.
And the really bright star is the Tau star. But they were wondering, if it was truly a member because it's so bright in that cluster. And I think they've decided that, it is. That's such a young cluster. Your stars that are going to, blow up one of these days, they'll evolve fairly quickly for the more massive stars. So that's probably a fairly massive star, right dead center in that cluster.
Yeah.
And so it's really beautiful in a scope.
Yeah.
And it can actually be observed in a 2-inch scope. So
like a little guy. Like here, I actually have a picture of one.
50 millimeter.
Like way
I'm sure your
over
binoculars
there.
would pull it in.
That guy.
There
He's
you go.
So
Yeah.
tiny.
As long as you got to have a good dark sky and good
Yes.
seeing. That's one of those things. If you're going to push your equipment, you got to have good conditions. If it's windy and there's high clouds or cirrus, or the scene's just really bad, give it up. Go for something like M41. That'll show up, in
totally.
really lousy conditions.
Or M42. Hey, Kent, before we do the winter alberio, can you answer a question? I'm grabbing my eyepiece case so I can pull it out, but we've had questions about filters that you've mentioned. Can you just explain real quick about an O3 filter while I grab it so people can see?
It turns out the O3 is what they call a narrow band filter, and it turns out it has like a real narrow band. I think it's like a 10 angstrom opening. It reflects everything else, and the band is about 5,000 angstroms around there. There's actually 2 lines for O3 that pop in. And the thing is, when you use that filter, it's really interesting. Our eyes are sensitive to 5,000 angstroms. It's like the peak of the green, and our eyes are sensitive. We can pull in green real easily.
Yeah.
So there you're screwing it at the end of the eyepiece.
This is how most people do it. And I'm going to go ahead, tell people how you do it.
There's another technique.
Yeah.
What you do is you take the filter and you move it between your eye and the eyepiece, and what they call blink the field. You just kind of blink it back and forth, and you've got to have like a dark cloth over your head. I have like a 3-foot by 3-foot section of just dark material, dark cloth that I throw over my head, and it really works well because that filter is so reflective. The starlight coming over your shoulder will reflect off the front of the filter and ruin the image you're looking for. Yeah, it's like a little mirror.
It's like a mirror.
Because it's reflecting everything except for that little band around 5,000 angstroms.
Yeah.
And, it just happens that most planetary nebula give off their light around 5,000 angstroms. And so that's what makes an O3 filter so useful for going after planetary nebula. I remember the neat thing is you'll have like a diffuse, reasonable sized planetary nebula, and you look in your eyepiece and you don't see anything at all, just stars. Then you blink the area and a whole disk pops out of nowhere. You got this glowing disk. Move the filter away, it's gone. It's kind of like a magic trick.
That's
and so
awesome.
that's a cool thing about an O3 filter. There's another filter called a UHC that has a wider band with it that's not so harsh. It doesn't blow away everything but the object. So that's another filter I use is the
Nice.
UHC filter.
Perfect. I actually have something I want to interject before we go to Winter Alberia. Would you guys like to see an image through a telescope right now, like a live image? If you do, just say, "Oh yeah," like so loud I can just hear you right now.
I can see Thor's helmet there.
Yeah, well, you can see it. I haven't shown it with everybody. So I didn't introduce Nico yet. He's amazing, has given us amazing views. This is his telescope right now. Can you see the outline of Thor's helmet? So you are looking through his telescope right now. Can you see that? Awesome. Let me just also bring up a picture of his telescope so I can share that.
The one thing is the helmet's laying sideways.
It is. It is. So it's here, and then do you see the feathers off the either end here? Nice. Nico, if you want to talk, you can say anything, or if you just want to be quiet, that's fine too. Oh, he is unmuted and ready to talk. Okay, perfect.
There,
so I'm just adjusting the stretch to bring it out a little bit more.
That contrast, got a lot easier to see it.
Okay,
that is cool. So you can see some of the filaments in the helmet.
Yep, so here's his telescope. Here he is. Now let's go back to his image. There you go. Go ahead, Nico, take it away.
You can see in some of the settings here, we've got a 15-second exposure. This is live stacking. And what it does is it brings out a little more detail in reducing noise. So we can see more of what's going on here. And I'm trying to stretch the image a little bit, bringing out some of the highlights so you can kind of see it a little bit better. This is all live. This is through the 8-inch Newtonian. And I'm using a, it's not a narrowband filter, but it's an IR pass filter. So this is infrared light from 642 nanometers to 842 nanometers. So you're getting H alpha and sulfur 2 bands. Those are emission bands. The O3 you're not seeing so much as. It actually cuts most of that out.
Awesome. If you guys like it, go ahead and write Nico a comment right now in the YouTube, on the chat right now. Thank you. That is amazing. Good job. All right. Kent, do you want to?
Cool.
Isn't that cool? It's like we just talked about that, and there it is.
It's a relatively faint object, so yeah, that is so cool.
That's awesome. Okay, so let's finish up and move on to our last constellation. We have Winter Alberio, which I had trouble finding. So let's go through it together.
Yeah, basically, if you go through all the work to find the Tau Canis Major cluster, then you should go for the Winter Alberio.
Yes.
Because from the Tau Canis Major cluster, there's a star right above it that's fairly faint, and but continues straight up from the cluster, and the Winter Alberio is about 1 degree and 40 arc minutes north of the Tau Canis Major cluster, and it's a little bit west, but not much. And so basically, it's like if you're at the Tau Canis Major cluster, swing on up, and there'll be a pretty double star. You know, I kind of see, there you got it, yellow and bluish tints to it. John Herschel discovered this double on January 23rd, 1835, and it appears as a magnitude 5.0 yellow star and a magnitude 5.8 blue star with a separation of 27 arc seconds. And this is not a binary system. The stars are totally unrelated. The yellow stars is about 2,280 light years distant, while the blue star is a lot nearer. It's 345 light years. And the reason they call it the Winter Alberio is the Alberio that you see in the summer, which is Beta Cygnus, it's also gold color and blue color.
Yes, it is.
So if you're going through all the trouble to find Tau Canis Major cluster, definitely swing north and take a quick look at the winter alberio, because it's one of those nice, colorful doubles.
Mm-hmm. Yes, and
it's fairly bright also. So
it is fairly bright. So just to kind of reiterate, we did a lot in the dog here tonight. So let's go back. So here, you're going to go outside. You look up. You guys can find Sirius now. But remember all the things we were looking at with the Canis Major. And so the first one, remember we talked about the open cluster. So you just go straight down. Here, let me make it bigger. Okay, you're just going to go straight down and you'll see it here. And this is a binocular object. Thor's helmet, this is one you're going to need a telescope for, because it's like ninth magnitude, right, Kent?
Yeah,
Okay.
the Thor's helmet,
Yeah.
magnitude 9, so, gonna need a bit of help on that one.
Gonna need a bit of help. Let me highlight it because it doesn't show up well here. So NGC 2359. Okay, so you can see it right there.
Boom! You can see there's nothing showing up like a little nebula there.
Yeah, it doesn't show up well. But so we went down this far to see M41, and then we're gonna take these two stars, go that distance twice, go up a little titch, and here it is. And you'll be able to find that. And then what he was talking about before, the open cluster of the NGC 2362, the Tau Canis Majoris cluster. Am I saying that right?
Right, you're saying Tau Canis Major cluster. You're
Yes.
correct.
Okay, great. 2362. It's the Majoris. Yep. I wasn't so sure about. Okay. And so you're going to look at the hindquarters. So if we put the lines back in, you can kind of see.
The hindquarters kind of point roughly at it.
They do.
I look for a pair of stars there, and usually it's real easy to find that pair. Mm-hmm. It's deciding in my telescope, since things are upside down and backwards. That,
yes.
I'll put the crosshairs or center the finder scope on one of the stars, and if I don't see a bright star with a bunch of little stars around it, mm-hmm. then I swap over to the other one.
Yep.
So it's either one or the other.
Yeah, and you can see if you just follow these stars here, they'll just point you straight to it. They kind of curve a little. And then straight up, you'll see the one he was just talking about with winter alberio. So right here. So everything is so tight and compact, and there's such great, there's so many good things to see.
The thing to realize is we're only covering just a few objects. There's a lot
more.
Yeah,
sure.
There's a lot to keep you busy until you're frozen, for this time of year. I mean,
I know.
You can go back multiple nights and get different targets. There's a whole mess of open clusters. There's, I think, another planetary nebula in there. There's just a lot of stuff because Canis Major is sitting right on top of the Milky Way.
Yeah.
And so that's where you've got all your good stuff, is right along the length of the Milky Way.
Mm-hmm. So you can see that here. So awesome. All right. So I know people have been waiting for us to talk about Orion. Just let me interject real quick. We are going to do another telescope view. Nico right now is working on a big, beautiful object in Orion. We're going to do that. If you've just joined us, I just want to say welcome. My name is Aurora with Central Coast Astronomical Society. Kent is our astronomer tonight. We also have Brian on as well as many astronomers that are typing furiously, answering all your questions. If you like this video, please go ahead and click the like button, click subscribe, and turn on that little bell notification so you will know next time we do our astronomy stargazing nights, and that way you'll get notified and so you can join us. Okay, so for Orion, are you ready? Okay, so Orion it's easy to find in the night sky. Just real quick, if you cannot find it, you're going to be looking south, and you're going to be looking, it's really high overhead-ish, and you're looking for those 3 belt stars that Kent had mentioned. And again, this is all part of that big winter well, there's 7 stars, but you called it a hexagon. Are there 6 stars?
Right, it's a winter hexagon. There's actually 7 stars, but Castor and Pollux go together.
Okay.
Treat them as one.
Okay, good enough.
We've got the winter hexagon out there, which is really nice.
Yeah.
And I think your chart is showing Mars over there.
Is it? Is that what that
See
is?
that orange star way over to the right?
It is
That
Mars.
yeah, I thought it looked too bright. There's nothing there, so it had to be Mars. Mars is a neck breaker right now.
Yes.
It's way up there.
Yes, and
So
I'm sorry, go ahead, please.
Oh yeah, I was thinking you also got the Pleiades. Is that really tight
I was
group?
just going to point that out. We covered that last time, if I'm not mistaken. We covered
yeah, we covered it under
the Bull,
Taurus.
Taurus, and we covered the Pleiades as well. So if you would like to learn more about that, you can just watch our stargazing session for January. Just because it says January doesn't mean you can't use it. A lot of that stuff is still up, and it's up for a couple of months. So feel free to go back and rewatch some of those stargazing sessions. Okay, and so we're going to cover Orion, and then we're going to talk about we're going to have another viewing session through the telescope, and then we're going to answer all the questions and about equipment as well as book recommendations. So, all right, Kent, here we go. This is the final hurdle. This is the one everybody keeps asking us for all year long. So, let's do it.
Okay, you want to do... Actually, you want to do the Orion Nebula then?
Let's do it.
Okay,
you can see this naked eye.
Actually, I can see the trapezium there,
yes.
right in the center. Yeah, that's the Orion Nebula.
Yes.
It's they call it the Great Orion Nebula. It's a starbirth area, or H2 region. It's actually a blowout in a great big molecular cloud. Those newly born stars, the radiation from them is ripping a hole in the dark cloud, and we can see into like an open blister. You can see the newborn stars, and the trapezium itself is actually only one part of an open cluster. You need infrared to pull in all the rest of the little stars that are hidden in the gas and dust. But one day, all that gas and dust will be blown away, and you'll have a neat open cluster hanging there.
Okay, great. And you know what, Ken? I don't think people see what you're seeing. I think you're looking through the telescope right now. Should we just share the telescope? That's what you're looking at.
Right
I'm showing the photographs that both Brian and Nico took. This is the picture that Nico took. This is the picture that Brian took.
Oh, okay.
But you're not looking at either of those.
No. What I'm seeing is a black and white.
Let's look at what you're
image.
seeing.
I think it's Nikolai's
yes,
image.
It is. Let's go see what you're seeing. Ready? Here we go. All right. Do you want to keep talking? And then, Nico, you can talk as well.
I know you had a pretty image on a little side thing. I wasn't even looking at the side thing, but
that's okay.
Anyhow, the Orion Nebula has a magnitude of 3.7. The size is about 90 arc seconds by about 60 arc seconds. It has a distance of about 1,300 light years. An older figure would be about 1,500. So I think they've gotten a little bit better with the distance. It was first mentioned by Nicholas Claude Piercy or something like that in 1611. That's not, far off from 1609 is when Galileo was playing with his telescope. And the interesting thing is, he made a drawing of this area. He didn't mention anything about nebulosity. Of course, he was using a really small refractor.
Nebulosity is what? Slow down there a minute.
It's the clouds you see there. Nebulas actually means clouds, I think, in Greek. And you can see that glowing gas and dust there. Mm-hmm. And right in the center, there's a real tight group there. That looks really cool. Right in the center, you can see what they call the trapezium, which is 4 little stars that are really close. And it's like a quadruple system. They're actually denoted A through D from west to east. And there's actually 2 other fainter stars, E and F, that if you've got really good seeing, I've seen them often in my 8-inch. You just have to have good enough seeing to pull them in. Mm-hmm. And infrared really shows you, if you go, a deep infrared photo, they've actually seen all these faint stars around there. Mm-hmm. And the cool thing is, back around the year 2000, they'd have the California Star Party at Lake San Antonio in the fall, and you'd be up till 3 o'clock in the morning, Orion would come up, and at that time the air would be super steady. And I remember you could see all 6 components, plus little holes in the nebula all over the place. It was almost like a spider web or something. It was really, really cool looking.
Mm-hmm.
And that just had to do with, that god-awful hour of 3 o'clock in the morning. The scene just got really good. And, I've never seen views of the Orion Nebula look like that.
Yes. Now, for those of you who are just wondering what we're looking at, this is a live view through a telescope. And so, Nico, are you there too?
I am.
Oh, great.
Yeah, so what I'm doing is just adjusting the histogram so we can see a little more detail in what's coming through on the camera.
Nice. You got a few people asking about your camera. What would you say? They're kind of curious
I'm
what
actually
camera.
It's a mono camera, but it's a guide camera. It's primarily a guide camera, and I'm using it to take images. So it's a ASI 290 mm mini, and I just put it in the 1 1/4 inch eyepiece holder. I'm not guiding; it's just firing away and stacking as we go. So I'm at half-second exposures, 300 gain, and the rest is just a stretch with stacking.
Perfect. Now, when you say stacking, for people that are brand new to astrophotography?
Right. So what it does is I'll turn this off. I'll actually disable it so you can see what the single frames look like. So this is what it looks like with a single frame, and you'll see it kind of adjust every frame it takes at half a second. And the higher the gain, you get more noise. And so when you stack an image, it averages out the noise, so you don't see it so much anymore, and you get a much clearer image. So we'll go ahead and start stacking this. See how grainy it is? We'll start stacking it and watch as that grain goes away, and we can see more of the detail.
Nice. Very nice.
For a while there, in the old days of photography, people were stacking negatives, actually physical negatives, to erase the grain in the photographs. And so this is like the same technique, but taken a light year ahead.
Faster, a whole lot faster.
Yeah, a whole lot faster, a whole less painful.
Yes. Oh, that's beautiful. Okay, we'll come back to you in a minute. Kent, do you want to move to talk about some of the major stars in Orion?
Yeah, let's. Can you get up a picture of Orion there?
Yes, I can. All right, so here we go. You look up in the night sky. Most people can find Orion. Just look for those 3 belt stars. Here, I'll take everything off. And we'll go for a walk around the block. Da-da-da-da-da. Tell me when you see Orion. You guys see it yet? Tell me if you see it.
I see it.
Oh, well, I know you do. There we go. You see the 3 belt stars? There we go, and a lot of big stars. Okay.
The other thing to point out is the 4 stars that make up like a box around the belt.
Mm-hmm.
You've got Betelgeuse, then you've got that other star I can't remember the name of that's relatively bright.
Bellatrix?
You drop straight down, and you've got Rigel,
Oh.
and then that other star I can't remember the name of, but it makes like a box, roughly a box around the belt.
Mm-hmm.
And then below the belt, you've got the sword that's hanging down, and that's where the Orion Nebula that we were just talking about is located.
Mm-hmm.
And then another thing is, out in front, if you go from Betelgeuse to that other box star and continue, there's like a long line of stars. And what they show in the picture is it's a shield that Orion is holding in front of him. He's holding a shield, and above, off of Betelgeuse, there's actually a club. There's a few stars that represent a club that he's holding, but there's not much there. So he's armed up. He has a club, he's got a shield, he's got a sword, so he's ready to bear.
Oh, well, in
In fact,
Stellarium,
they're showing it's an animal.
it's an animal, not a shield. But yeah, I think I've always heard of it
depends
as a
on
shield.
Yeah, it depends on which mythology you're going with.
Yeah.
And
Okay,
there is
great.
a mythological thing concerning Orion and Scorpius. Orion's a winter constellation, and Scorpius is a summer constellation. And the mythology is that Orion was kind of a braggart. He made the gods angry. And so they sent a scorpion to kill him, sting him and kill him. And after they killed him, they had buyer's remorse. And so they put Orion on one side of the sky and the scorpion on the other side of the sky so they never meet again. And that's something I remember from a long, long time ago.
Yeah. Wow.
So anyhow, that's one of the mythological things about Orion the Hunter.
Now, there's a lot of things in Orion. We're just going to hit the highlights here real quick. Okay, go ahead, Kent.
Okay, we'll start off at Betelgeuse. Great. Alpha Orionis, basically the so-called bright star. But the thing is, it's a irregular pulsating red variable star. It's also a supergiant. Betelgeuse means the armpit of the giant when translated from Arabic. At least I hope it does. That's from the sources I read.
Keep going.
It's listed as the 11th brightest star in the sky with an average magnitude of 0.7. This star can vary in brightness from magnitude 0 down to magnitude 1. So it usually fluctuates between those, 0 at the brightest, and then magnitude 1 at the dimmest. But during the great dimming from late 2019 to early 2020, it dropped to magnitude 1.61.
Yes.
So it got quite a bit fainter, and people were worried about it going supernova.
I remember
it hit
that.
The lowest in February 2020. And what happened was it actually blew out a great big bubble of carbon and helped dim it down. It had like a dark spot on there. And John Herschel first noticed the star's variability in 1836. Betelgeuse is about 430 light years distance. It's 55,000 times brighter than the sun on average. It was the first star to have its diameter measured by a beam interferometer on December 13th, 1920 at Mount Wilson Observatory. Its diameter is 650 times that of our sun. So if you replace the sun with Betelgeuse, its surface would be out towards the asteroid belt.
Wow.
It's also the first star to have its surface imaged by the Hubble Space Telescope. And right now, it's core burning helium into carbon and oxygen. And so it's on its way to blow up one of these days. But it could be, tomorrow or a million years from now. You just never know. And the next star is the beta star, Rigel, which is blue supergiant. It's actually a blue-white supergiant. It's also a binary. Rigel is from the Arabic Rajel Jajon. I butchered it, but it means the left leg of the giant. I dug that out of one of my books.
Nice.
It's the 7th brightest star in the sky, so it's a fairly bright star with a magnitude of 0.1. Rigel's 23 times the mass of our sun, about 43,000 times brighter. It's about 860 light years distant, so it's quite a bit further than Betelgeuse. It has a companion with a magnitude of 6.7 and a separation of 9.0 arc seconds. And I've seen it easily in my 8-inch quite a few times. It's kind of like an easy double. It's just you've got to, realize that you've got a really bright star and a relatively faint star next to it. William Herschel discovered this companion on October 1st, 1781, and the companion itself is a spectroscopic binary with a period of 9.86 days. People have seen the companion with a refractor as small as 2 inches.
Wow.
With good steady seeing. So,
that's really small. So like that little white guy is 80 millimeters. So that's a little bit bigger.
Problem then,
no problem.
If the seeing is steady.
If it's steady, yeah.
And M42, we kind of talked about that one. And that's the central star in the sword of Orion, or actually it's not a star but a nebula.
Yeah.
And in binoculars it shows up real easily.
Really nice.
750s, 1050s, and in fact, when I got my 20-inch, it was the first object that I looked at through my brand new 20-inch. And around the trapezium, I remember I could see green. So the 20-inch pulls in enough light so you can actually see color around the trapezium.
Mm-hmm.
And then at the outer edges of the cloud around the trapezium, I could see like a dirty orange color. So that really blew me away. I knew I had a good scope.
Wow, that's
when I
awesome.
could, see that with the first light with my my 20-inch.
Now there's another one there, M43.
Yeah, M43 is actually really part of the same nebula, but there's a dark lane that separates M43 from M42, and M43 is a lot smaller. It's only like 6 by 3 arc minutes, has a magnitude of 6.8. It was discovered by Jean-Jacques de Marian in 1733, and it's just a small, it looks like a 7th magnitude star with a little like almost like a comma mark around it. And in fact, you can see that comma mark in that picture there, but you can't see the dark lane separating out M42 from M43, but there is a dark lane running there.
Okay, great.
So that's actually a nice photo of
Brian took that one.
Yeah, that one's a nice photo.
Do you want to move up to Sigma?
Yeah, let's move up to Sigma because that's really
that's where all the rest of
multiple
it is.
Star, and it's easy to find. You find the belt, you go the eastern star, which is Zeta, and you drop down at a right angle from the belt stars, and there it is. That's Sigma Orionis. And Sigma Orionis is a multiple star system. The actual star itself appears to be magnitude 3.7, and but it turns out that the star that you see is a really, really close double that most amateurs won't go for. They call it Sigma A and B. They're just very close, separation of 0.25 arc seconds.
Oh wow,
so
that's close.
That's I think someone was using the Lick 36-inch refractor.
Yes.
It appears as a single yellow star in amateur scopes.
Okay.
And so it's not something, maybe if you had miraculous seeing and a big scope and high powers, but that's really pushing it when you're getting down that small of a separation. But anyhow, on the western side of the AB pair, there's a star at 11.5 arc seconds called Sigma C with a magnitude of 8.8. And it kind of looks like a faint little star right next to the AB star. And then on the eastern side, at 12.7 arc seconds, is Sigma D, and it's got a magnitude of 6.6. So it shows up a lot easier. And then finally, further on the western side at 41.5 arc seconds is Sigma E with a magnitude of 6.3. So it kind of looks like a line of 4 stars in my 8-inch scope.
Wow.
And so it's really pretty. In fact, you've got the drawing there.
Yeah.
That shows the C, it shows the AB as a single star, and then the D and E there. Yeah. And they look roughly like they're in line. They really aren't, but, good enough.
Yeah,
and
yeah, exactly. So
and the cool thing about Sigma is you can just look up and see it naked eye.
Yeah.
It's just you follow the belt, take a right angle from Zeta, and boom, Sigma's right there.
Yeah. So let me back out a little bit just so you have context. So here's Orion.
Yeah, you've got to gives it a good context because you see the 3 in the belt,
and
you take a right angle to Zeta's the easternmost star. Just make a right angle from like drawing a line through the belt, and boom, a right
Perfect.
angle to the south, and Zeta goes.
Yep,
So
that's great.
that takes care of Zeta. You want to go for the showpiece?
Yeah, we
item?
just have a couple left here, and then we have another
Okay.
telescope view. So B33, the horse head. Let's
The
just
horse
zoom
head.
in. This is the one everybody likes.
It's mainly people see it in photographs.
There he is,
and
right
you
there.
can see the horse head with that background nebulosity.
Yeah. So wait.
It's about 1,200 light years away.
Mm-hmm.
It's located about half a degree south of Zeta. So you just drop down a half a degree. It's a dark nebula. It's actually a cloud of probably carbon dust.
Mm-hmm.
It's about 6 by 4 arc minutes, and it's silhouetted against an emission nebula called IC434, which is probably caused by Zeta illuminating that nebulosity.
Mm-hmm.
Of course, the shape of this dark nebula looks like a horse head, hence the nickname. And Wilhelmina Fleming discovered this on a photographic plate in 1888 at the Harvard College Observatory. And so I've actually seen it in my 20-inch out at Navajo Flat.
That's awesome.
Without a filter. A lot of people use an H-beta filter to, that background nebulosity. It does help with the contrast. But I was using a 2-inch eyepiece, 32 millimeter, and I was just surprised how large it looked.
Yeah.
I mean, we're looking at like 79 power, and I kind of missed it at first because how big it appeared in there. I was looking for something small. Then I realized that this big thing, like if you split the field in half, it would take up like about upper quarter or something. It was really prominent, good sized, which really surprised me. And so I was really happy to see it.
Now there's another one here people are asking about. They're like, what is this thing?
Oh yeah, the Flame Nebula. It's really a cool nebula. It's NGC 202 or 2024, and it's right next to Zeta.
Yes.
There, Zeta's that eastern star, so it's real easy to find it. It has a magnitude of 7.2 and a size of 30 arc minutes by 30 arc minutes, and it's about 15 arc minutes northeast of Zeta Orionis. It was discovered by William Herschel on January 1st, 1786, and to me it kind of looks like a bright nebula with a dark tree of nebulosity superimposed on it.
It does.
So,
Here's it's sideways here. This is a picture that Brian took.
Oh yeah. You can see that dark lane with kind of offshoots from it.
Mm-hmm. It does.
It's a dead tree, but
And we only have one. I'm sorry. Go ahead.
Oh yeah, with infrared, there's actually an open cluster forming in that. That's actually a starbirth area.
Wow.
So in infrared, there's all sorts of young stars buried in there. When they get going, they're going to blow away all that gas and dust.
Yeah.
And there's going to be a neat open cluster right next to Zeta.
Yes, and we're just in this area, this little teeny area. We haven't really moved. So
yeah, there's a lot of bang for your buck.
You get a lot in this area. This is that star he talked about. Here's the horse head. Here's the flame. If you go down to the belt, there's M42, M43. So these are all in this one area. The reflection nebula is not here, though.
Well, that's actually a little. You can see it in the right up there. See that?
Yeah.
That's M78.
And so, which is
nebula.
right here.
You can see it's about 2.5 degrees northeast of Zeta.
Yes.
You can spot it in 1050 binoculars. It's about 1,300 light years away. It's got a visual magnitude of 8.0 and a size of 8 by 6 arc minutes. And it was discovered by Pierre Merchain in 1780. And so that's all the specs on that. In fact, a friend of mine, Jay McNeil, found a new nebula in there in the lower section of N78. It was some star turned on and lit up a chunk of the nebulosity. He took a photo of it and found this new nebula, and now they call it McNeil's Nebula. but it got all sorts of the professionals excited when he happened to mention that on Am Astro.
Wow.
And they named it after him, so I thought that was really cool.
That is really cool. Now, Brian, are you... Oh, I'm sorry. Go ahead, Kent.
Oh, no, go ahead. I'm finished.
Oh, okay. Well, I was going to say, Brian, do you have another view for us? Let's see if I can pull you up here.
We do. Yes, we do. We
Yay!
have a nebula called the Running Man Nebula. Nico has it ready.
Okay, great.
So, Nico, I'll just kind of like ask you over voice here. If you wanted to go ahead and share your desktop, we can switch that over. And let's see if we can see the slight silhouette for the Running Man. Or we might switch to one of our other images. I have it on mine where you can see what appears to be a side view of a person running, which is where it gets its name.
That's awesome. Nico, do you want to say anything?
Yeah, so I was going to try and show this one. It's really hard to pull out, but you can see, I don't know if I can show. Aurora, are you able to show it in Stellarium?
Yes, I can certainly do that. Do you have...
So
okay, I'm sorry, go ahead.
It's an interesting nebula because depending on the bandwidth that you're imaging at, it'll appear differently. Like I've seen it really blown out in some images where they pick up less of the dark nebula through the center, and it looks like a really bright region. But in some images, like color cameras, will show more blue and more red. So it'll be really well defined. This one it's kind of faint, but I'm also imaging just in the red.
But it's still great to see. It's a nice nebula.
Yeah, do you want me to show your image? Would that be better? I didn't look.
Yeah, let's bring up the one of either Nico or mine's image.
Okay, let me do that because the one on Stellarium isn't terrific. How about this?
Okay, so the view everyone sees on mine, that would be the nebula on the left in the image you see is what Nico is showing. And so if you can use your imagination, if you imagine this little dark lane in the middle is the sideways view of a person where it's the person's torso. And Aurora, I know that you're kind of having to go off of your arrow.
Oh, I know. I'm looking for it. Is it, are we looking in here?
It's, yeah, so it's over, no, the nebula to the left. So the whole other section separate from M42. That's the section. And then right in the middle kind of looks like, maybe could look a little bit like an X.
Yeah.
Right there, your arrow's on the very bottom of his foot. If you go up, that's it. That's the Running Man right in the middle.
Got it.
So, with his two legs.
Let's see. Let's take a look at this one. So over here?
Yep.
It does look like a Running Man. I don't think I've ever,
there you go.
I've never really known that one. That's awesome. I learned something tonight.
And so that's Nico's image that he's taken. So this shows what his color camera can do with some processing.
Beautiful.
Very
These
good.
are
Yes, so there
amazing.
you have it.
Awesome. Thank you.
And so then, by the way, if people are wondering about that one has a different kind of number. And I was going to bring it up here. Kent, do you by any chance know the designation for the Running Man off the top of your head?
I don't have it off the top of my head, but I assume it's like an NGC.
It's actually an SH number, too, is how I usually see it. Let me just bring it up really quick.
An SH number. Yeah. I have...
So usually it's sharpless, I believe. So it's SH2-279.
Oh, that's Shapley.
Yeah, Shapley.
Shapley made a list of nebula along the the Milky Way galaxy, and SH is Shapless 2-. They're usually 2- something on there. I wonder if I can see it on my star charts here.
Yeah, so it has the designation Sharpless 279.
Okay.
And
okay, that'd be I'm thinking either it's 2-79 or it's 2-279.
No, you're right. Yeah, 2-279. And then Aurora, to what you were saying, Aurora.
Yeah.
There's actually 3 different NGC numbers for different parts
Different-
of that nebula.
That's what I kept seeing on my chart here. Okay.
1973, 1975, and 1977.
Yes, those are the ones I'm
And
seeing.
then right above it is an open cluster 1981.
So it just goes to show there's so many fun things to go after. Just this one constellation.
Yes, and we didn't even cover everything. We just kind of highlighted the ones to see for tonight.
Oh
Okay.
yeah, there's a lot of stuff there.
Absolutely. Well, thank you guys so much for joining us. If you have 4 more minutes, we're just going to answer a couple of quick questions that have come in, and I really mean 4 minutes. A couple of quick astronomy recommendations and books and all of that sort of thing. Before we do, though, make sure you leave us a note in the chat. Let us know how you liked tonight's presentation. Again, your sharing this video and liking it and subscribing is the highest form of the highest compliment you can give us for our show for tonight. So thank you so much for joining us. And so Brian, I'm going to put you on just for a second. Say hi to everybody. So thank you,
Hello,
Brian.
Thanks everyone for joining us.
Thank
And
you, everyone.
Thanks Kent and Aurora for a great presentation.
Yes, and thank you to Nico for the telescope views. That was amazing. He did this at the last minute, by the way. This was not really planned. And so he said, yep, I can do it. Let's do it. And so thank you again, Nico. And thank you, Kent. I have a whole bunch of questions about, I want to buy a telescope now. Thank you so much, Kent. People wanting to run out and buy things. So don't do that just yet. Hang on. A couple of really good resources. If you don't have a subscription yet to Astronomy Magazine or Sky and Telescope, these are great. If you are looking to become a member of our club, it's $20 a year, which is a deal for your whole family. And you actually get magazine discounts. So you can go ahead and check out our website, centralcoastastronomy.org. And I should probably put that up down at the bottom, centralcoastastronomy.org. Oh, well, you can figure it out from the link there. A couple of other quick things. If you are new to astronomy, this is a great book to start with. It's called Night Watch, and I personally like it because it lays flat when you're doing your astronomy. And so this is by Terence Dickinson. This is a great one. There's a number of great resources. I'm just showing you a few. Touring Through the Universe. This is another one. This is by Philip Harrington. This is another great resource, as well as Kent's favorite. You ready, Kent?
Yep.
This is Kent's.
The Stars by H.A. Ray. Real easy book to learn the constellations with.
Yes.
I mean, it came out in like 52 for the first edition, and it's still in print after all these years.
This is the guy that did Curious George, so if you recognize the last name.
If you go to like Barnes & Noble, they still have copies, or if there's any used bookstores open in this time of the COVID pandemic, used bookstores will have old copies, and the old copies are just as good as the new copies.
Yeah, totally.
And so, it's a real good beginner's book for learning the constellations.
It is. And honestly, the best thing to get is not a telescope, right, Kent? What's the best thing new beginners should get?
The best thing to do is get an old pair of binoculars.
Yes.
If you don't want to spend much money, go to yard sales or a swap meet. The thing is, when you look through the binoculars for used binoculars, make sure the images coincide, that both eyes see the same thing. If the images are slightly out of whack, someone has dropped those binoculars and knocked the prisms out.
Yeah.
Do not buy them if they're that. I mean,
no.
It would cost so much money to have them fixed. It'd be cheaper to go to Big Five and buy a brand new pair.
Yeah, and binoculars, you don't want to go any bigger than, honestly, for kids, 7x50s are great. Grown-ups don't go any bigger than 10x50s. These are going to serve you very well because telescopes are pretty useless if you don't know where to point them. So by watching our stargazing, being a part of this community, we'd love having you here, and also just taking these star charts that we talked about at the beginning, going outside. You've got the ones you circled. We covered a whole bunch. Take the handout with you and go just learn the night sky one constellation at a time. If you're thinking, wow, you guys covered a lot, how am I going to do it all? Just take a couple of the objects that you're really excited about. For example, just Orion. Look around Orion's belt with your binoculars, with your naked eyes, and just see if you can see anything. In fact, just finding the different, like Betelgeuse, and finding Rigel, and finding where Capella is, just knowing where the things are in the night sky is really the first step to getting started. Initially, a lot of people go outside and they get overwhelmed. It's like, wow, there's a lot of stars, it's dark, and there's no little Aurora's pointy things aren't in there, and she's like not connecting the dots. That's okay. Just you can rewatch the show as many times as you want to, and just get more and more familiar with the star patterns, and just take it one little step at a time. We all started there, right, Brian? We all started not knowing what anything is.
Right, exactly right.
Yes, exactly.
Yeah, I didn't even know what the belt of Orion was.
Right.
Till I got, I saw those 3 stars and go, what is that?
Yeah.
And then, had the started with the H.A. Ray book. And the thing about the H.A. Ray book, it has good overlap between the constellations on the chart. So you can see what's next door.
Yeah.
And you can build off of that.
Exactly.
And so, it really helps having a chart. And, if you can get an old pair, I'm using my grandfather's naval binoculars, which are 750. They weigh a ton. I had to build up my arms, the muscles in my arms, so I could hold them steady.
Yes, let me talk about that. You can get a $30 pair from Celestron called Cometrons. They're 7x50s. They work great. If kids drop them, it's only $30. It's okay. It's not going to break the bank. So you can get them new as well. So speaking of tripod,
they're a lot light. Have you noticed they're a lot?
They're lighter? A lot lighter. Yes, they're very light.
My grandfather's weigh a ton. In comparison to the newer binoculars are a lot lighter.
Yes.
So you don't have to build up big muscular forearms to hold the thing for any length of time.
Very true. I wanted to we've gotten a couple of questions about this. So these are 25 by 100s. These are enormous, so you would never hold these by themselves. They have their own tripod underneath. This behind me, this is another telescope. This is an 8-inch, just like Kent was showing his orange 8-inch telescope in the beginning. It's a Schmidt-Cassegrain. And the one I was showing and pointing to a few times over there, this is actually, when I point to this, and I usually say don't buy a telescope like this, it's too small to do anything really. Honestly, you're better off with binoculars than trying to like fiddle with that and trying to get it to go to the right. Here, let me show you a picture of it. Trying to, where's my finger? Right there, that white one. I actually got that as a demonstration of what not to use, and it was really inexpensive. So I've gotten these because people give them away for free because they get frustrated. So so don't get those. Also over there, oh, you can't see it. This is the also do not get. You see it way over here. Oh, there's me. Way over here, this telescope right there. So it's not really useful for anything. Here, I'll just go pick it up. So again, I don't want to spend a lot of time on this because we made a whole handout. But if you see like $20 telescopes, $50 telescopes, leave them there and don't buy them. So this is like a doorstop. So it's a cute concept, but it doesn't work well. It frustrates people to no end, and your money is better off spent on a guidebook or a pair of binoculars. Okay, so that's my spiel for equipment. If you would like more of our recommendations, please check the last page of the handout. It's right here. It has all of the links and everything that you need, including mounts for your cell phone, so you can take little pictures of what you're seeing in the night sky. All right, we are going to wrap things up. So, Brian, do you have any last announcements, maybe for our next stargazing event?
Yes, I wanted to be sure to let everyone know we have 2 other events scheduled. We try to do one of these virtual stargazings once a month. So the next one is on March 13th and then April 10th. And again, it'll be a Saturday at 7 p.m. Pacific.
Perfect.
So we'll see you there.
Yes, and for those of you who are really enjoying, hang on, Brian, I'll get you in a second. That really enjoyed our show tonight. Make sure you like us and subscribe and become a member of our club if you'd like to do that. We'd love to have you as a part of it. You can be from anywhere in the entire world. And if you have anything you would like to share with Kent or with Nico or myself or with Brian, let us know in the chat box right now. We're going to end in like 60 seconds, so go ahead and let us know how you've enjoyed tonight's show, what you like most, so we can do more of that. And we've really been enjoying this. In fact, Kent, we were just talking that this next one that we do will actually be a full year, because I believe we started in March of 2020, and so
right. So this is our 12th show.
This is our 12th show. Yes, it is, because we pre-recorded one back for Halloween.
Halloween one.
The Halloween one, yes. So we've actually been doing this for a whole year, and we've really enjoyed it, and we're going to keep going. So for as long as there's an interest. So we want to hear from you what you guys think. So
Aurora, one thing I found out was the shows. If you go onto YouTube and you search under Central Coast Stargazing, they'll all pop up. I mean, I don't know if you've done that or tried that, but they're
no,
on
I haven't.
YouTube.
That's awesome.
From the first one we did, they're all there. And
nice.
So all you have to do is go on YouTube, the search thing at the top, right? Central Coast Stargazing.
Perfect.
Get that, and bang, they all drop in.
That's great, and you can keep watching them from last year. It's the same objects again this year.
It's the same shows are about an hour to 2 hours, in length, but they're all there on YouTube, stored away.
Yes,
and so I thought I've told people, if you want to see it, just go to YouTube and plug in, Central Coast Stargazing.
Perfect.
And they'll all pop up. My cousin back in Utah, she really loved the Halloween one.
Yes, and we actually have a surprise for March that Brian and I are working on. And actually, Kent, don't give it away. Don't tell the secret yet. We're going to give that away soon. And so one last question I can answer. Tutorials on Stellarium. Yes, if you contact the Central Coast Astronomy, so just go to our website and contact us, hit contact and ask for that. We will email you a link of a video I put together that shows you how to use Stellarium, and also there's another video that shows you how to use this thing, and it walks you step by step through all of those. And so those videos I think are like 20 minutes long each, and so if you just send us an email, we'll send you a link to that as well. I don't think they're on the main. We should probably put them on there, but we just haven't. So yes, thank you. Okay, and Brian, do you have any other announcements? It looks like
I will say we had some questions on the chat because of a side conversation that occurred with a fellow club member. I'm actually in Southern California and a member not only of Central Coast Astronomical, but Riverside Astronomical in Riverside, California. With that club, our outreach team does a virtual stargazing in conjunction with UC Riverside. So we had a mention on the chat about our Thursday presentation. If you're interested in that one, you can Google UC Riverside Astronomy, and then they also have a Facebook group, and you can see that there and find out more information about those meetings.
Perfect. Okay, great. Yeah, I saw that, and I was wondering what happened on Thursday. I must have missed something. All right, everyone, have a wonderful night. Get outside, go look up, and really be amazed by what you see at from tonight's session, and you'll be surprised by how much you actually remember. So thank you, Kent, for your time. Thank you, Brian. Thank you, everyone.
Right.
Thank you, Nico.
Thank you, Aurora.
Bye-bye.
See you later.
See you guys later. Have a wonderful time, and share this with as many people as you can. Take care, everybody.